All right, in this lesson, we're going to be tackling a little problem that has to do with my game character's movement. If I go up and press play scene, you can see that with the arrow keys on my keyboard, I can move around my level quite nicely. As the last few lessons in this course, we've also added the letters A and D on the keyboard to spin the camera around the player so that when you move, the movement is in relation to the direction of the camera, so the controls always feel great. However, the problem with our game character and its movement is right now when he moves up and down slopes, he doesn't orient or tilt to match the direction of the ground. If my little character was a vehicle, like a car, driving up and down a slope would mean that the character would tilt to match the direction or the orientation of the ground. We're going to fix that in this lesson so the character always isn't moving just flat to match the horizon. Instead, he'll tilt up and down on the floor as the floor tilts. What we're going to actually have to do here is make the game character, Steve, recognize the direction of the floor that he's directly on top of. If you want a character or a game object to know the direction, in other words, the normal is the direction of any 3D polygon in a 3D environment. If you want Steve, the game character, to recognize the normal direction of the surface that he's currently on, well, we're going to actually add a little helper into his scene. I'm going to go ahead and on my Steve node here, which is a scene, I'll go ahead and open up his scene by clicking on this little clapboard icon right here to jump on over into the Steve scene. I'm going to select his root node and I'm going to add a special kind of a node called a Raycast 3D. A Raycast 3D, if I select the root node and then press plus to add it, I can find it under the Node 3D branch of all the available nodes. In Node 3D, there is a node here that I'm looking for called Raycast 3D. A Raycast, I'll go ahead and press create, is essentially a walking stick or a laser beam that shoots down from wherever the Raycast 3D begins. I'll go ahead and hide the actual mesh to see this raycast. This raycast is this bluish area here that points exactly 1 unit down. And if I select that raycast, of course, I could rotate it if I want to point in some other direction. However, the default here is actually okay, so I'll press Ctrl Z. This raycast will be able to give us information about anything that collides with it, including the direction of any ground that our character is currently on if it's pointing straight down. Now, by default, if I have that node selected, the Raycast 3D, it is enabled, which is good. It will not detect collisions with its own parent, so we don't want the Raycast to detect a collision with the character itself, so it'll ignore that with this option turned on. The target position, in other words, how far this ray casts downwards and where it stops, is decided by these values right here. If I change this value on the y-axis to -2 and I press enter, well, the ray will search further away from the character downward. We don't need that. The ground's not going to be that far away from the character. So I'm going to revert these to all the default settings, down -1 on the y-axis. Collide with, well, we want Raycast 3Ds to collide with physical solid objects, which is turned on by default. Collide with bodies is on, areas is off. If you want a Raycast 3D to detect, let's say, the coins in your game, well, you can enable areas to be turned on, but we're going to leave them turned off. Now, I actually haven't changed any of the settings for my Raycast 3D, but that's okay. The default is just fine. What I should do now is press Ctrl S to save, because the majority of the work here is going to be done in Steve's code. So I'm going to go ahead and click on Steve's script icon right here to bring up his code, which I'll go ahead and maximize on the screen and make a little bit bigger. Now, what we're going to be doing in code is a little bit tricky. If I go ahead and take a look at my 3D scene in level 1, essentially what I'm going to be doing here, if I go ahead and actually turn Steve's visibility of his mesh back on so we can actually see him, and I'll save that. If I go ahead and take a look at Steve, I essentially want to be rotating him to match the information that Raycast 3D is passing back to Steve about the orientation or the normal direction of the ground that that raycast is currently touching. Now, this does involve a little bit of tricky math that we're not going to get too deep into in this lesson, but what I do need you to understand is that when you want to control the rotation of a physical object like a character body 3D, you're going to be working with what's called a transform 3D. In Godot or in GScript, there's actually a class that your character body 3D uses called a transform 3D that contains what's called a matrix of data. Essentially, a transform 3D is a 3x4 matrix with 3 columns and 4 rows that's used for linear transformations. It can represent transformations such as translation, which means movement, rotation, and scaling. It consists of a basis, which is the first 3 columns in the matrix, and a vector 3 for the origin for transformation. It has many properties and many methods in it, and essentially we're going to be using and manipulating this transform 3D of our game character to orient our character in real time to our ground. So what I'm going to do in GDScript on my character's script here is actually make a new variable up at the top, right under my other constants here. I'm going to go ahead and click at the end of this line and press enter a couple of times. I'm going to make a variable here called transform, but transform is actually already taken. The transform of my character body is already called transform. So I'm going to call this variable Xform. This Xform variable is going to be of a type called transform 3D. And by the way, when I declare a variable with the keyword var, and then I use a colon, and then I tell that type of variable what kind of data it's going to be, this is an optimization to your code. Essentially, you're making a variable that can only have one type of data that you can't change later on to some other type of variable, like an integer or a string or something like that. So this variable is going to be used actually to hold a copy of the game character's current transform so that we can manipulate this transform before we actually make our character transformed like the updated version. Now, a little bit lower in my code, in my physics process delta game loop function, I'm going to find the section right after I get the user's input. Right here on my line 33 to 35, I have the code that rotates the character's mesh using the player's input on the keyboard to make the character face in the correct direction. I think right here is an optimal spot to rotate the character to match the ground as well. This code right here, this if and this else, I should probably give it a heading as well in comments. I'll put a little hashtag to make a one-line comment. I'm going to describe this code as update the velocity and move the character. I think that's a pretty generic description for all of these lines. Right above that section of code, I'm going to make a section with a little heading here that says rotate the character to align with the floor. That's a pretty nice little description. In this section, I'm going to say if the character is on the floor. So I'm going to say if is on floor, which is a method that we can call on a character body to see if they're resting on the ground. If they're on the floor, what I want to do is call a function that I'm about to write called align with floor. I'm putting some code into a separate method here that I'm about to write because I think it's good to segment code that you're writing into smaller functions whenever possible. So I'm trying to emulate that in this process of writing this code. In fact, one of the things we can do when we're designing a new function that we're going to write is we can decide if we're going to send that function a piece of data called an argument or a parameter. In this case, this align with floor function, I'm going to send it the direction or the normal of the floor that the character is currently touching, or the character's raycast is currently touching. So I'm going to send it here the raycast's collision normal. If I go into Steve's scene so I can see his nodes here, including that raycast, I can target that raycast and I can say, hey raycast, what's the normal direction? In other words, the direction of the floor of the thing that you're colliding with, which is the floor. So if I say, hey $raycast 3D, which is the name of my node here, and I say dot, I can now call any method that this raycast can perform. If I say dot get collision normal, which is right here, that should work. So now I'm going to write this method called align with floor and send it the direction of the current floor. And this align with floor function should rotate my character. So let's go ahead and scroll down. And at the very beginning of align lower down here, I'm going to make sure that I'm not tabbed in at all. I'm going to write a new function called align with floor. And by the way, it's complaining at me right now. It actually just went away because it couldn't find a function called align with floor. But now that I've started typing it, that error has gone away, which is nice. So I'm writing a function called align with floor. It needs to accept a parameter or an argument. So I'll put my round brackets right here, and I'm going to call this argument floor underscore normal. So when we pass this method the direction of the floor from our raycast, it'll store that data in this variable called floor normal. I'll put a colon at the end of that line and press enter. This function needs some code in it. So what I'm going to do here is take my Xform variable, which I'm treating sort of like a global variable, which is sitting up here at the very top of this code, which means that if we declare a variable at the very beginning of our code above the physics process function and our custom function down here, then any function, either physics process or aligning with floor, can access that variable without having to make a new variable of that name in the actual function, if that makes sense. So what I'm going to be doing here is taking our Xform from up at the top of my code and making it equal to my character's current transform. We're making a backup or a copy of our current transformation. So I'm going to say Xform equals, and we're going to use the property or the variable of this character called global transform. So global underscore transform. Make sure you don't choose rotate instead of transform. It is transform. Okay. On my next line of code, what I'm simply going to do to start off here is simply make the Y direction of this new temporary Xform and make it match the Y direction of the normal of the floor. So I want the direction, my up direction of my temporary Xform to match the direction of the way that the floor is facing outward from the floor. So I'm going to take this Xform, and I'm going to access its Y direction by saying Xform.basis. The basis, if I flip back over into my transform 3D, the basis is a major part of this transform type of an object. This basis includes both rotation and scaling information. Again, this goes beyond the scope of this course, but the basis contains many numbers for X, Y, and Z that tell that object how it should be scaled and rotated in each direction. I think that's as far as I'm going to go in terms of that math and that type of object. If I want to rotate a character, I'm going to change its transform basis, and I'm going to make the basis.y match the floor normal. Let's go ahead and do a Control S to save. The last thing I need to do here is actually, if I'm on the floor, back up in Physics Process Delta, this is the section that we just wrote a moment ago, is I'm going to take that temporary transform and make it my actual global transform. So on the next line of code, right on line 40 here in my code anyways, I'm going to say make the global underscore transform equal to my Xform copy that I have rotated. Let's go and see what that does. If I Control S to save, and I make sure I have my level 1 scene active, and I go up to play scene, what's going to happen? Well, I can still move around. That still works fine. However, when I go up a slope, you can see that it doesn't quite work the way that I want. But you can actually kind of see here that as I go onto a slope, Well, the Y direction of my game character is actually pointing perpendicular to the direction of the floor, which is what I want, because we've made the Y direction of our character's basis match the normal of the outward pointing direction of the floor. But we haven't done the rest. Our character is skewed and we want it to not look like that. But it is sort of working right now. Let's go ahead and keep going. What I want to do now is in this align with floor function, I want to keep going because obviously when you change just the character's transform basis.y to equal the floor normal, that isn't the whole story. So on the next line of code in this align with floor function, I have to line up the other axes as well. Now, just to give you a visual representation, if I jump back into my 3D workspace and take a look at my gizmos here of my character, these arrows with the different colors, green for up and down, which is Y, which is what we used and made match the normal of the floor. If we only change the transform basis of that axis to match the normal of the floor, well, it leaves the blue Z and the red X axes unmodified, and that's why we're getting a skew happening. What I need to do is a little bit of complicated math to align the X axis as well, called a cross product, and then we need to orthonormalize our entire basis of our game character to make all three axes perpendicular to each other in 3D space. Confused yet? Well, hopefully just understand here that if we make the Y direction in the basis of our character match a new angle based on our floor normal, we need to make sure that the other two axes line up the way that they should to make an unskewed cube tilted on the ground. So back into my game character Steve Scene and back into his code. There's a few more lines of code to write here, just a few. I'm going to take the Xform, its basis, and make its X direction equal to the negative Xform dot basis dot Z dot, and we're going to get the Z axes cross product with the floor normal. So essentially, we're taking the negative Z direction of our character's basis and doing some math with it along with our floor normal to get a perpendicular direction, which we are then assigning into our basis X direction. Okay, one more line here. Once those two directions are calculated, I need to then orthonormalize, which means to make perpendicular the entire basis in order that the Z direction is also in line and perpendicular. So I'm going to say make my Xform, actually its basis, equal to itself dot basis dot orthonormalized. Orthonormalized is a method that we can call that will straighten it all out, assuming that two directions are already correct, as far as I know. So I believe that should work. If I press Control S to save, that is it for that function. Align with floor is now done. If I go back up to my level 1 scene tab and press play scene, how does it work? Well, I can move my character around the ground, and if I go up a slope, hey, there we go. It aligned. Now, you'll notice that it kind of snaps, right? There's no nice transition here. And I want a nice transition. I want it to smoothly, translate or rotate from this angle to the floor angle without just snapping. So what I'm going to do here is not in align with floor, but up here where I'm calling align with floor, what I'm doing on this line 39 is I'm getting a new rotation for my character in terms of its new Xform. Its Xform is being modified down here in the align with floor function, but this variable Xform is up at the very top of my code right here. So in my physics process delta game loop, I'm getting a new temporary direction on line 39, and then I'm actually applying it on line 40, but I don't want to just make it snap to the new rotation and make it do that on that frame. I'm going to take the global transform and assign it to itself, but blend it in using a function that's a lot like lerp. Lerp, do I have it in this code? I think I do somewhere. Yes, it's right here. It's a way you can transition from one value into another value. Well, with a global transform, what you can do is use, I'm going to go ahead and say global transform equals global transform dot, and there is a method called interpolate with. So if I type dot int, it'll be the first little prompt for me there. Interpolate with requires two values. It requires a transform 3D, which we know is Xform. This is the destination transformation that you want. And then you put a comma for a second argument, and then you use a weight, which is an amount, a percentage that you want it to transform every time the game loop runs. In this case, I'm going to try 0.3 for 30% every 60th of a second. So I'm going to press Control S to save, and with my level 1 scene active, I'll press play scene. And now if I go up the slope, hopefully you'll see that transition right there, and it's a little bit more smooth, and that looks pretty good. How does that one look? Pretty good. Now, there's a few issues with my game. If I jump with the space bar, I want my character to straighten out when they're in the air, right? Because right now, when the character jumps, it stays tilted like the floor that it was just on. I don't want that. So in my character's code, in the game loop, we have this rotate the character to align with the floor section. I've said if my character is on the floor, rotate to match the floor normal. However, we're going to use an elif here. I'm going to say aligned up with my if, I'm going to say elif not is on floor, and I'll press enter here. I'm going to use the same two lines of code again. So I'll copy these two lines of code, Control C, Control V. However, I don't want the character to align with the floor when they're not on the floor. So I'm going to replace this code right here with simply an up direction. If I say vector3 with a capital V dot up, I can make my character rotate to face, well, upward, and that should work. So I'll press Control S to save, and with level 1 active, I'll press play scene. And now if I jump, well, that works. If I go to a ramp, that seems to work. If I jump, see how it straightens out? I quite like that. Now, there is one outstanding issue in this code that you might encounter if you try to stop your character right on an edge at the top of a slope. So let's see if I can find this for you quickly. If I go right to an edge, there it is. You can see that my game character's raycast 3D is getting confused. If I were to put a little print in my character's code to print out the normal of the floor, I'm going to try copying that code, and just in a little temporary line up here, I'm going to print out the raycast's collision normal. In other words, which direction the floor is facing. I'll print it out 60 times per second so you can see what's going on here. I'll save that. I'll press play scene. If I go around my game level floor, you'll see that the ground is pointing straight up. There's no tilt on the X or Z axes, but the Y direction is 1, which means straight up. If I go to an angle here or a ramp, you can see that that is the angle. It's a vector 3 of that angle of the floor's normal. If I go back to a floor, horizontal, that's fine. However, if that raycast is right on an edge, it might flicker back and forth. How do we stop that from happening? Well, to be honest with you, I don't have a good solution yet. But what I'm going to try here, I'll get rid of that print line, is I'm going to say if I'm on the floor and if I'm actually moving, then make my character orient to the floor. But don't try to fix it every single 60th of a second. Only fix it if they're on the floor and if input direction, in other words, which direction they're pressing on the arrow keys on their keyboard, is not equal to a vector 2 that is 0, 0. So 0, 0. What this means is if they're not pressing anything, it won't do these two lines of code. they have to be on the floor, and they actually have to be moving, which means they'd have a vector 2 from their arrow keys on their keyboard that are not 0, 0. Hopefully that makes sense. If I press Control S to save, and now I press play scene, if I move around, it still works. I can jump. I can go to a ramp. That works. The only problem with this code, and now I don't have that problem, is it'll still perhaps happen if I'm moving directly along an edge like that. And because it's not going to fix my angle if I'm just sitting there and not moving, if I jump and land, well, it doesn't fix my orientation right when I land because I'm not pressing any arrow keys on my keyboard. So it's up to you. You can keep that extra bit of code. The and input direction is not equal to vector 2, or you cannot. There we go. Either way, it should work pretty good. And so now we have our character aligned with our floor. And when they jump straight up and down. There we go. So on the screen right now, if you'd like to pause the video in case you didn't get every single line of code, we have the code that we just typed today in our game loop in physics process delta. And then we have that extra function that we made called align with floor. The only code that I'm not showing you on the screen right now is up at the very top of my code of my game character. I made a new variable called Xform. It's a transform 3D. That's up there. Otherwise, down here is all of the code from this lesson. That will be it for this one though. Thanks again for watching. We'll see you in the next one. Bye-bye.